So for section 5.2, we're going to talk about composition of functions. Typically what this means is you're going to put one function inside of another function. So what I'm going to do in the little space under where it says composite function, I'm going to make a little chart here. So I have the domain of f. I have the range of f. And I have the range of g, because we're going to be dealing with two functions, f of x and g of x. All right, so when I input, so if I input of f of x, I put that in, then what I'm going to get is the output of f of x. Okay, but now in terms of composition of functions, if I do the input, and I know this can be a little confusing, I promise it's not too bad. Input of g of f of x, that leads me to the range being the output of g of f of x. So when you're asked to do a composite function, whether it looks, you're going to see it like this, and that's not fog, that's not an O, but composition of functions, that's sort of the symbol for it, or you're going to see f of g of x. What that means is the second function goes into the first function. That's how you do it. So the function composition, it's not commutative. So if you do f of g of x and g of f of x, they are not equal to each other. So let's just practice right now, just identifying. Don't so much worry about the domain and range. We're going to just do the composite functions. So we're going to do this one, which means the same as f of g of x. And then we're going to go the other way. G of f of x. Okay, so for f of g of x, that means that we're going to put the g everywhere we see an x in the f of x function. So our f of x function is 2x minus 5. So instead of writing 2x, that x is now going to be replaced by the 4x, because that is the g of x function, and then we simplify. So f of g of x is 8x minus 5 when you simplify. For g of f of x, now the f of x is going into the x in the g of x function. So instead of writing 4 times x, you're going to write 4 times 2x minus 5. And again, you're going to distribute, and you get 8x minus 20. So you can see they're similar, but they're definitely not equal to each other. So don't assume that they're going to be the same. All right, for b, let's try another one. So we have f of g of x, which means the same as this. We have g of f of x, which means the same as this. So again, the second function is going in place of the x in the first function. So the first function is we're starting with the f of x function, but instead of the x, we're going to replace that with what the g of x function says. Now in this case, we have to FOIL, because there's 2x minus 6's. So that gets me x squared minus 12x plus 36 plus 2. And when I simplify that one step further, I get x squared minus 12x plus 38 for the f of g of x. If we go the other way, here's my g of x function, but instead of the x, I'm going to put the f of x function in its place. And then when I simplify, I get x squared minus 4. Now, another type of thing that's incorporated with this is definitely word problems. So this is just one instance down below. So it says Hector has 100 deducted from every paycheck for retirement. He can have this deduction taken before the state taxes are applied, which reduces his taxable income. His state income tax is 4%. If he earns $1,500 every pay period, find the difference in his net income if he has the retirement deduction taken before or after state taxes. Okay, so let's see here. So for each paycheck, he has $100, okay, deducted. So his deduction for retirement, we can create an equation. So we can say f of x equals x minus 100. So x is what he's starting with, okay, in terms of what his pay would be. Now, for state income tax, we're going to make that g of x, and it's saying his state income tax is 4%. Okay, find the difference. All right, so we're going to take his original, what he makes, And now we're going to take 4% of what he makes, and we're going to subtract, and we're going to get basically what he's left with is the 0.96. So we have to come up with our two functions. Now we have our f of x and we have our g of x. So now we're going to figure out retirement before taxes. So that's column 1. And then we're going to figure out retirement after taxes. Retirement after taxes. So if we're going to do retirement before taxes, if the state income is g of x and the deduction for retirement is f of x, then that means that for retirement before taxes, that would be our g of f of x. Okay? For retirement after taxes, that would be the flip of that, which would be f of g of x. Okay, and now it's saying he earns $1,500 every pay period. So that means your x value is going to be $1,500 because that's what his pay would be. So that is our x value. So I'm going to sub that in. And now it's a matter of doing your composition of functions. Now, what you can do, though, is we're actually evaluating it. So we're going to evaluate the inside function first because we don't have to sub anything in. If you want to sub stuff in, you absolutely can do that. But if it's saying f of 1,500, well, f of 1,500 means that we're going to sub 1,500 into the f of x function, which means we take 100 from that and we get 1,400. Now, if that is your f of 1,500, that now has to be subbed in, and now we're taking g of 1,400. And g of 1,400 means I have the 0.96 times the 1,400, which gives me 1,344 for that part. For the second one, now I'm going to do g of 1,500, and I'm going to take the 1,500 and multiply that by the 0.96. All right, and then what you get for that particular value, you would then take 100 from that when we do that. I don't have this exact value here, so sorry about that. So I'm going to take that. You don't need to write it this way, but then when you do f of x, you're going to take the number you would have just gotten and take 100 from that. Sorry, this is 1,400, my bad. And then you get 1,340 for that. Okay, so if we look at these two values, 1,344 and 1,340, that means that the net pay is $4